what I want you to see in this video tonight is that we can have the same amount of space or goals that we've been talking about with fundraising, but that the fractions are totally different. So here's an example of 3 different goals. So you can see how much this group would be. They would have raised half of their goal. There are 2 sections, so that gives us our denominator. There's 1 that's shaded in, and that gives us our numerator. In this other example here, I could have this section and this section shaded in. I can see that they are exactly the same, but this time instead I have 2/4 because there were 4 sections, 1, 2, 3, 4, and 2 of them were shaded in. So I can say that 1/2 and 2/4 are equivalent fractions. Just another one with that same thinking is that I could say here that I have 1, 2, 3, 4 sections. Again, you can see that they're all the same. 1, 2, 3, 4, 5, 6, 7 eighths this time, and that I have 4 eighths. So I could say that 1/2 is equal to 2/4 is equal to 4 eighths. Those are all equivalent fractions. I could also say instead of doing with the bars and the thermometers that we've been doing, instead we can just look at the fraction part and keep the fractions the same, but just with different numbers, the same values. So the very first one here is 1/2, and I can say that if I double my denominator and I double my numerator, they stay exactly the same value. So this 1/2, just back to this, like this, would be the same as 2/4. We're just cutting those halves into sections. Sorry, that was pretty poor half there. That we could say that this, there we go, sorry, that this half here is the same thing as this half here in terms of space and when it's being taken up, but that the numbers are different, but we're just dividing into the same number of sections. We could just as easily also say that I'm going to multiply the numerator by 3 and my denominator by 3. So I could say that 1/2 is the same thing as 2/4 is the same thing as 3/6. One of the many super cool things about this is that I could multiply the numerator and denominator by the same thing, whatever number I want, and they'd be exactly the same. So if I want to multiply my numerator by 100, I want to multiply my denominator by 100, all of these fractions are all equivalent. So equivalent means they're worth the same thing, just with different numbers. So 1/2 is equal to 2/4 is equal to 3/6 is equal to 120ths. So just keeping in mind that situation is that then we could say, like, is that I could take anything, like I could take 30, 36. And an equivalent fraction, I could have it be the same value but with bigger numbers. So again, I could multiply numerator and denominator by 2. Oops, sorry. So I'm at 70 seconds. I could multiply it by 5 if I wanted to, and I'd get 150, 180. Those are all the same thing. But I also just as easily could do 30, 36, and instead divide it by the same number. So here I'm going to divide my numerator and denominator by 2, and I would get 15/18. And these are the same values. This and this are the same value. I could also instead say that, looking at my first one, that they're both divisible by 6. So I have 5 and 6. So I could say, it's sort of amazing, I always think it's amazing, is that every single fraction on this screen, this one, this one, this one, and all of them in this row are all worth exactly the same amount if I put them on the thermometer chart. They look different from each other, but they all would take up the same amount of space. And just so you know, for the very first question tonight, my favorite kind of ice cream is black raspberry. Bye. Have a good weekend.